Hi, I'm Brian Harvey. I'm supposed to be introducing Mary, which I will do. I've been working closely with Mary since we started the high school version of BJC, because she was a key developer on the team, and has continued to work on BJC even after the money ran out. Which is extremely dedicated of her. She is also, let me get this right, a circus art performer and a physics graduate student specializing in quantum. And so she has wide-ranging interests. And I'm very, very pleased to introduce Mary Fries.
Thank you, Brian. Welcome, everyone, to my presentation, A Curriculum Developer's Favorite Projects. So a little bit about the curriculum we're talking about. I think probably many of us are familiar with one or both of these curriculum, but in case you're not, I have been working with Brian and with Dan on the Beauty and Joy of Computing CS Principles course and Beauty and Joy of Computing Sparks. And I wanted to say a little bit about each of them. BJC CS Principles is an AP Computer Science Principles course for high school endorsed by the College Board. It's a full year course. It's about, it has 8 units and they cover abstractions, higher order functions, recursions, and a lot of the social implications of computing. This course has been developed for well over 7 years. I think I've been part of it for 7 years. It's fully developed. There's a teacher guide. There's ancillary supports for teachers. It uses the Snap programming language. Woohoo! And here's the link, bjc.edc.org. BJC Sparks is a relatively new curriculum. It's for middle school and early high school. It consists of 3 units designed for a whole year. About functional programming, sequential programming, and hardware. And those are kind of our 3 basic units. We start off with that functional first approach. We get into sequential programming once the functional programming is, those foundations are laid strongly. And then our final unit is about hardware. That curriculum is still in development. We have over a year of development happening now. We had a phenomenal group of pilot teachers last year. And last week, we actually had 55 more teachers come in. We were trained by some of our teachers from the first year, and it's just an exciting project. There's a lot going on there. We use Snap and we use microblocks for the hardware components, and there's some links here at the berkeley.edu address for the student materials and the teacher guide. But first, one of my new favorite projects, I just built it, I think last week, a little bit about me, just to follow up on Brian's introduction. So here's my little Snap bio sketch that I've created. And unfortunately, I don't have the strongest Wi-Fi connection, so we might have to be patient for a moment, but here we are. Hi, I'm Mary Fries. I use she, her, or they, them pronouns. I live in Winchester, Massachusetts, and I'm a STEM curriculum designer. I've been writing for the high school at BJC AP CSP curriculum for several years, and now I'm writing for BJC Sparks. I'm also an artist, a physics graduate student, and I train in the circus arts. That's me on top. Welcome to BJC. So a little bit about my criteria for favorite projects. I chose projects for this talk based on their learning potential, which I kind of characterize in 2 ways. One is the ability to allow students to experience to explore materials in experience before formality format. So what that means is that they're playing with the blocks, they're building things, they're experimenting before we give a formal treatment, say this is what this block does, and this is how it works, and these are its inputs, and these are its possible outputs. So we really try to take that approach in both our curricula to teach students through a hands-on modality. I also chose projects that would be nice for review. In some cases, the projects that you're going to see today are used after students have already learned something through an experience before formality approach. So I'm choosing projects, as I always do in curriculum writing, that I think will lead to great learning gains for students. I'm choosing favorite projects based on appeal, projects that are fun or entertaining, or maybe they're useful, practical to students in some way. Projects that afford a sense of agency for students, so leaving them room to customize the project or bring their own creativity so they can see themselves as part of the process of creating programs. I also chose projects with potential for extension, so things that can be added to the project, opportunities to go further. And while I don't think it's a requirement for every project, in fact, I think students can and certainly should be building their own complicated projects. I chose projects today that had a certain simplicity or elegance about them. I like projects that teach new ideas in a simple context and then allow students to expand on them as they're building their own creative projects. So look at that bio project that we just saw a moment ago. How does it meet those criteria that I created just for the purposes of this talk? Teaching potential. Well, we've got sprites. That was the little pictures moving around were sprites. They have costumes, and I was swapping out the costume. We can incorporate motion. We can incorporate timing and events. Students are working with sequencing. In fact, we can take a look at what the code is behind this. For most of us, this should be relatively familiar looking code. It's just a sequence of commands, but we do have some timing elements because, of course, if we went too quickly through the code, that wouldn't be preferable to folks experiencing our biography. I think of this as being a fun project and a useful project. It's nice for getting to know your students and for them getting to know each other, or if you're working with teachers, to share and learn about each other. Sense of agency, the project is all about you as the programmer. So it really gets students a chance to feel like they're part of the computer programming process. They're building something that's about them, sharing their interests. And of course, there's tons of potential for extension here. One of my favorite ideas is to do, instead of biographies on yourself, or maybe in addition to that, doing bio sketches on professionals. So you can focus on computer science or data science careers, and you can also look at representation and making sure that students are seeing a variety of different faces of folks in computer science so they can see themselves reflected in the field. Another new project that I'm excited about, this one we developed last year for the BJC Sparks curriculum, is the Super Short Stories project. And I'll just pause here and say something about the way I've constructed the links in these documents. The first link is a link to the project, and the second one is a link to the curriculum materials. I'm not going to click that link today, but we are going to, I just wanted you to know where it was. We're going to go ahead and look at the project. So this project is kind of like that old familiar Mad Libs paper-based activity where we ask folks for a random sound, a random noun, a random color, and then we read back this really goofy story because nobody had any idea of the story that they were creating. So this is a modification of what's currently in the BJC Sparks curriculum and probably closer to where it will adjust and settle down for the upcoming school year. We've abridged it significantly from what was in the materials, and we're going to allow students to expand. So we have this super short story block. Students can click it and see what happens. It says the happy teacher looks up the tree and jumps. And I've just remembered that it's really nice to zoom in a bit so that you can all see pretty well. So we can type different things in here. Maybe it's an excited, let's see, doctor who cries. They're excited. They're so excited they're crying. So what happens? The excited doctor looks up the tree and cries. So then we give students these random blocks that'll give them a variety of different jobs, different actions, different feelings. This is a very introductory project. This is something that happens right at the beginning of the year when students aren't familiar with block-based programming languages. They're not familiar with the drag and drop. They're not familiar with the ideas of random or putting any given block inside of another block. So we're building up that familiarity through this fun context. So now we can start taking these random blocks and dropping them in super short story. We get a different story every time. The nervous nurse looks up the tree and snores. The angry musician looks up the tree and snores. The angry landscaper looks up the tree and talks. Maybe he's got a lot of work when he looks up that tree. So you can do a lot of different things with this. You can build your own super short story. You can create new random blocks to go with it. This is a great project for customizing for students, not only because they can create their own stories, but they can translate into their own languages. And forgive me, Spanish is my second language, not my first, and I'm by no means an expert, but I did take a pass at creating a cuento mi corto, which is a very short story. It takes a job. It's got the article as well, because in Spanish that changes based on the gender of the noun. It's got a feeling, sentimiento, and an action. And la maestra feliz mira hacia el árbol y salta. The same story, but now it's in Spanish. So what I like about this project is you've got this teaching potential for teaching with functional programming. So you'll notice there are no command blocks here. It's all about dropping blocks inside of other blocks. We've got inputs, we've got the opportunity to create blocks, and we've got randomness happening. So there's a lot of different things we're having the opportunity to explore here. It's a familiar type of activity. A lot of kids have done Mad Libs or similar activities. It's entertaining because you get silly results. There is certainly lots of room for creativity. And of course, you can rebuild the project in other languages, or teachers can actually create variations on the blocks for students who have limited English proficiency. And then of course, there's loads of room for extension. So you can create blocks to solve grammatical issues. And as we all know in English, those seem to be unending. So you can get all kinds of funny things because of English grammar. Just as a quick example of a nice extension that's pretty easy to do is, let's say instead of saying a feeling, we wanted it to be a number. So we could say super short story, and we take in a number as input. And I'm going to rename all on this feeling block. So now this feeling down here got renumbered. So I'm going to have some number of a job looks up the tree and does something. So let's see what happens. Well, first, instead of having a random feeling, I'm going to pick a random number. And I get the 3 musician looks up the tree and wanders. So we gave a couple extra blocks to students, one that takes plural, one that takes a word and makes it plural. So I can take this random job and make it plural. The 4 artists look up the tree and wander. So we're getting closer. And I can also remove the last letter of a word. So I can just take that S off. The 5 cashiers look up the tree and climb. We can explore tense and work on that. So maybe we want to have them past tense looked up the tree. But of course, now we've got this incorrect last word here. 9 plumbers looked up the tree and talked. So we can actually join that last word with ed to get it into past tense. And these are interesting problems for an introductory student to solve. So you can just have a very simple project where they're getting to know blocks and dragging and dropping and maybe making some edits to the structure of the story. Or they can get a little bit more advanced and play with some of these blocks, or even perhaps create variations on the plural of word block, such as what if the word ends in X or in CH, how should that word be constructed in those cases? So there's lots of room for extension here. Another exciting project that I really like is from the BJC High School CSP curriculum. It's called a quiz app. And basically what we have in here is that ubiquitous idea of offering a quiz and gathering results. We've all taken quizzes on the internet. This one teaches abstract data types. So we have quiz item with a question and answer, and then a question and answer selectors. What I really like about this project is that it lends itself to abstract data types naturally. So every student immediately understands why the question and the answer have to be paired up. You can't just ask any random question from your list and match it to any random answer in your list. They have to be paired. So it's a natural way to use abstract data types. So let's get this out of the way for a moment. And we've got this constructor here, so it just makes a list of the 2 things we're adding in, our question and our answer. And we can set our variables. So we're learning about variables. I don't even think I have this on the slide. So we set our variable to equal a list of our quiz items. And we've got that list over here showing up as our variable. And now we're teaching list traversal. We're teaching user input and output, and we're teaching predicates and conditionals, all in the context of this quiz project. So I'm going to go ahead and hide this variable. since I've limited real estate. What is the computer science term for looping or iteration? Gosh, looping or repetition? Gosh, I don't know. Maybe it's sequencing. Sorry, the correct answer is iteration. So it's a very simple project. And you'll notice that this is a nice one in the sense of it being a block-based language, because we're not involved in getting tangled up in nested braces or dealing with semicolons. We're all very familiar with this. We're all on board with Snap. But I like this for an introductory project because we can go to this advanced level of having list traversal with a nested conditional, and it's relatively accessible to an introductory course student. So we're teaching abstract data types, predicates, conditionals, user input, and list traversal. Quizzes are super popular across the internet. Everyone has seen them. It's ubiquitous. We are getting that sense of agency for students. They're able to create a quiz about whatever they like. Of course, I, being a computer science curriculum writer, wrote my quiz about computer science topics, but students can write their quiz about anything. It could be about music, it could be about cars, it could be about their neighborhood. It really allows students to engage in it in their own way. And then there's opportunities for extension. You can have students counting the player's score. So in this case, we're just saying, either you're right or you're wrong, and here's the answer. But you could have them counting the score with an additional variable. You could also create variations. You could create features in your project to allow for variations. So maybe I ask the question, let's see, what are my questions? Okay, here we go. What kind of variable is only in the part of the program where it is defined? Maybe I want to accept not only local variable, but also local or script variable. I could create a variation to accept various inputs. So I want to have a little bit of hands-on exploration time. Let us break up into, maybe we could do some breakout rooms, Brian. If you're up for setting that up, maybe, how many folks do we have on the call here? 68. How about,
Let's try.
Let's do 10 breakout rooms, or actually let's do 8 breakout rooms.
8.
Yeah, we'll do eight rooms and set people up in them. And here's what you're going to work on.
You want to do assign automatically?
Yes, but as soon as I'm done here, but that'd be great, Brian.
Okay. Yep.
So we're going to have an opportunity to work in one of these projects, just to play with it a little bit and share something fun or silly that you create with someone else. So super short stories project, you can create your own variation of the super short story, maybe add some elements to the story, maybe translate it to a language we haven't seen yet. You could work on the quiz app if you wanted to, creating your own quiz or trying one of those extensions, such as counting the player's score or accepting variations on inputs. Or if you want, take a moment and create a biography project. So we'll have, let's go into groups for about 5 minutes just to play and build some things. Then we'll come back together and let a couple of people share something fun that they built. No need to have a perfect project. We just have a few minutes. Just bring us something fun to take a look at. So share in your groups, and then maybe 1 or 2 of you can come back and share. We'll come back at 40 after, so 20 up. And we'll share them. 5 minutes. Thanks, Brian. All right, welcome back. I just wanted to say someone popped in and said they didn't have the link, and I apologize for not sharing that earlier. If you're looking at the SnapCon page, you can find the link to the slides right here. All the links are in the slides, but I'll just go ahead and drop it in the chat for everybody so that you have it. This is the slide deck here. All the links are in here. I apologize for not
share
saying
our
earlier.
screen.
Sorry, what was that? Oh, Brian, could we allow participants to share their screens?
Yes.
So now it's over. Now it doesn't.
Well, you can share with us now, and we'll have another exploration time toward the end as well. So you can hopefully have access to things and share them. Were you able to get that, Brian?
Yep, everybody can share.
All right. So for those of you who were able to access the links, is there anyone who would like to share some project that they've done? I know you had 5 minutes or less, depending on how long it took you to get those links. But is there anyone who'd like to share something? Again, it doesn't have to be perfect, just something fun so we can see some variations on these projects. Oh, I'm sure we've got somebody.
Well, it wasn't really worthwhile. We had only two blocks. That's all.
Oh,
And,
did you build 2 blocks?
huh?
Did you build the blocks?
No, just two separate blocks and saying the name and how do you do, and that was all. And then it was time.
Okay, okay. So this sounds a little bit like a project that we had in BJC Sparks, where we would say hello, and you type in your username or your name, and then you could choose a language from a drop-down selector. So it would say hello in different languages.
Okay.
Has anyone used either of these projects with their students? I saw someone mention, I think Bob, you mentioned that you had used the super short stories with kids. Do they want to comment on working on some of these projects with students?
Don't all shout at once.
Yeah, Bob may not have heard you, Mary, or maybe he's not here.
How about you, Dave?
I used it in my classes. The kids loved it.
You use the super short stories?
Yeah, from last year, the earlier version that was a little bit more complicated.
Mm-hmm.
And I made a fuss about it being complicated, and now I see it's shorter. So it's nice to know that feedback enters the system and makes change.
Right. Yeah, we haven't updated the student facing pages yet, but that'll be next, and it'll happen before you get started in September or late August, as the case may be.
That's great. Yeah, because with the more complicated version, I just found some students got confused about what they were supposed to do, partly because there was just so much information there presented.
Mm-hmm. Yeah, so Dave is referring to an older version of this project where we had a lot more going on in the story. And in fact, if you look at that link on the page here, up at the top, this BJC Sparks Lab 1.2, you'll see it much more complicated stories. We're simplifying that for this year. Students can add additional complication if they want a more complex story, but we're keeping it simple to start with. Brian, I saw a comment in the chat about not being able to find the reporter block. And I wanted to just mention a little bit about something that we're doing on the BJC Sparks curriculum that we didn't do on the AP CSP curriculum, which is early on, we're giving students a limited selection of blocks so they can really focus on specifically what we want them to work on. And as they become more familiar with Snap and with block-based programming, you start to introduce more and more blocks until they're just running free range in the traditional Snap interface. There are ways to show and hide blocks that aren't currently appearing in the palette. One way is to right-click in the palette and say hide blocks, and you can turn off which blocks are hidden. So this participant was looking for the report block so that they could create some new random blocks. So you can just unhide and say okay, and then report shows up here. Brian, I was also curious, is there a way to escape this mode and just get right back to the baseline Snap interface?
Yes, if you go back to hide blocks, if you
Okay.
open that window, now right-click in the background of that block.
Ah, okay.
And if you select none,
Now we're hiding none of
and
the
then
blocks.
click OK.
Great.
Yeah.
Wonderful. Great question. All right. We could talk more about these. We'll have another time to chat later, but I want to move on to my next favorite project on the list, which is a song player project. So this one we created for the BJC Sparks curriculum. It's in fact the first lab in Unit 2, which makes it the first sequential programming students see. They've seen a command block or two along the way just to create some output on the stage or to get some kind of, I think it's mostly to get things up on the stage that they were working on if they were doing some mapping and functional work with images. But they haven't been sequencing blocks. They haven't been snapping any together vertically. We've saved all of that for Unit 2 and focused strictly on functional programming. So our introduction to sequential programming, I'm pretty excited about because it uses visible stepping together with a sound project. So you're seeing the iteration and the nested repeat blocks here at the same time as you're hearing it. And to me, that's very exciting. You should be able to hear this. I'm going to go ahead and turn on visible stepping here, which I think is an excellent Snap feature. It's been around, I think, longer than I have, but it's wonderful, and I really love it for this context. So I'm actually going to zoom out a little bit so you can see the whole code. And here is our little demo of the song player. So as you can see, it's a very simple project. We're just going through our Mario Brothers theme song with a different instrument each time. But what's nice about it is you've got this nested repeat. So you can see it's going through 4 times. Each time it's setting to a different instrument. And we've also got this nested repeat inside, and we can see it at the same time as we hear it. So instead of learning iteration and nested iteration in a fully abstract way, we're not only seeing it, but we're hearing it at the same time, which I think is very strong for students to be learning how iteration works, how sequencing works. We've also got this timing component because it's music. So you're really seeing every next block continues. In particular with this, with these play note scripts, the next note doesn't play until the previous one does. So I'm very excited about this project. We've also got some variations on the project as we go a little further along in that BJC Sparks lab, where instead of using individual play note blocks, we have a play song block that will take a list of notes as input. And then students, of course, have already learned map because in Unit 1, it was all about functional programming, and they're able to map a change in pitch over the notes in the song, and you actually are able to transpose sequences of notes. So here's an example of that. So again, very simple, very familiar song, but a very nice example of map, and gives that auditory element as well. So we're learning about sequencing, we're learning about iteration, and we're getting visual and auditory cues. It's fun, it's useful for creating music for a larger project. So if you have a game and you want to make a funny little music song in the background, we saw some really excellent music projects for those of you who were at a talk yesterday, the name of which I have forgotten, but I think it was something like Make and Learn. Feel free to correct me in the chat. But a really nice project that's worth going and taking a look at if you didn't go to that session yesterday. I believe it was a workshop yesterday morning. But this is much simpler, but still nevertheless useful for adding music to a larger project. Endless room for creativity, especially your music kids are going to love this. One thing I wanted to show you, which you may or may not be familiar with, is that Snap has this great feature where you can actually type in a number for the pitch, or you can just select it from this little keyboard selector, which just opens as soon as you click that down arrow. And that's a feature you can add in as well if you're making a block. And let's see, I'll make the sound block. If you click the block and you go to this little cog down here, you can grab a, let's see, it's a piano keyboard menu. So I just went in to edit my variable name. I went to this little cog and said, I want to have a piano keyboard menu. I say, okay, okay. Of course, I haven't coded anything for my block, but lo and behold, I get that little menu. That's a feature that I love personally, and I'm really excited to have used on this project. Extension, we're using list traversal to play each note in a list. We can use map to transpose a set of notes. And then of course, there's endless room for kids to build on these projects. I call these extensions because you could just start off with sequencing and iteration and end there. And you could go on if you wanted to and do for each, you could use map and so on. So I think in BJC Sparks, we actually do a for each And then we say, gosh, wouldn't it be easier if we just had a block play song that does the for each for you. And another project I'm quite fond of, in fact, we're so fond of this project that it appears in both BJC curricula in slightly different forms. In BJC Sparks, right away in Unit 1, because it's a functional project, we've got the Cipher block that you're seeing at the bottom of the screen here. We're encoding a message and we're shifting it by 3 Unicode characters. So you see those spaces become hashes and the exclamation point becomes a $sign. In CSP, we have it in there in the context of cryptography, meeting those AP standards for cryptography and message encryption. And this is the project, this is the one from the Sparks curriculum. So we start off very simply. Again, this is Unit 1. We're a little more familiar with blocks at this point because it is Lab 5 and that super short stories was Lab 2. But again, we're still getting familiar with blocks and block-based programming. So we're learning about these 2 blocks. We can go back and forth between text and Unicode. We observe that you can actually take the Unicode of a whole word all at once. And instead of getting a single number, you get a list of numbers. And because of hyperblocks, which was an amazing addition last year, that I believe was announced at SnapCon, you can add 3 to each number in that list of Unicode for letters. So we've got our Unicode set of the BJC letters, and then we're adding 3 to each one. And then we can change that back into letters. So now B becomes E, J becomes M, C becomes F. We can join them back together and we get EMF, which is our encoded BJC. And so what we ask students to do is to generalize this process to work for any message and any shift value. So they get this empty shell of a block, and we have some blocks that we can use to construct our code, and then we can create little messages and encode them for each other. So we're learning about nesting functions. We're using our hyperblocks. We're learning about cryptography. Of course, this is universally appealing. Humans across time have wanted to encode messages. It's readily useful, and it's something kids in class do. They're passing notes back and forth to each other. Well, now you can make it a secret note, and only students who know how to decode your message will be able to do so. It offers a lot in terms of agency because you're creating and decoding your own secret messages. And we've even had more advanced classes create and crack their own ciphers. So that's an option as well. And there's plenty of extension opportunity. You can use mod to wrap around the alphabet. So right now, as you can see down here at the bottom, because we just have a shift through Unicode, if you take a really big shift, you can actually push out of the alphanumeric area of Unicode and end up with a bunch of symbols that maybe you've never seen before or might even appear as squares or blanks. That's fine. It will still decode correctly, but it might look funny. So as an extension, you can use mod to wrap around the alphabet. So a Z shifted by 2 wraps around and becomes a B. We've also had classes create a frequency analyzer to decode ciphers that were not done with a shift. So in addition to doing the Caesar cipher, which is just some kind of a shift by some number, you could replace different letters. You could, you don't have to necessarily do a shift as you're replacing letters. So E could become P and F becomes J, and you can kind of have a more random key for your letters. And that is a little trickier to decode because you can't just try all 25 shift values until you get an answer. So you can use a frequency analyzer and kind of match it up against the frequency of letters in the English alphabet. We have had some classrooms explore that. So again,
Mary,
yes.
Mary, do you want to just, sorry, if you just a quick question, did you want to just talk about the value of Snap to allow you to make a Parsons problem kind of puzzle by giving the blocks to use out there? You can't do that in a text language, and it's just so beautiful the way you've set this problem up, and I just want to maybe point that out of how nice Snap is to be able to do what you've done to show, here's the blocks you're going to use to make the message block. I don't know if you want to talk about that for a second.
Yeah, I mean, I think you've said it, Dan, here. That is what we're doing is we're saying, here are the blocks that you're going to use. It's kind of similar to how we've limited the palette over here on the left, but now we've been really specific. You're going to create this message block using these floor blocks. And you've got to think about, what kind of inputs you have, how you want to use them together, and then how you want to use them with these blocks, nesting them inside of each other to get this block to report the shifted message.
But what bothered me was that the very thing above it, the join Unicode, you could just drag that in there and then replace the two constants with the variables. You don't need to assemble it because you gave the answer right above it.
Oh, you mean right here?
Yes, you could
Yeah.
just drag that in there and then you got the answer, right?
Yeah, absolutely. You could do that, and you could drag these in. This is an example project, a demo created for our session here today. In our curriculum materials, students might see this block and talk about it, but this isn't exactly how it's taught in the classroom.
Okay, right.
So they aren't given this right there like that. Although in some cases that might not be the worst thing, because we might be, the goal of any particular activity might be to have them realize how these values are working together. So it really just depends on the context, but you're absolutely right. You could do just what I showed right there and you described with this project. So again, this is a demo created for you today to see something that might otherwise take the full hour of our time to explore. Great point, though. Other questions or comments? So again, I'm going to give you some hands-on exploration time. I will drop this link in the chat again, just so that everyone has it this time. I apologize that I didn't think of that before. All the links are in here, and I can also put links to the projects as well. Let's see if I can do that easily. Song player. And in just a moment, I'll ask Brian to put us into rooms again. And again, it's just a chance to play around and to explore these projects. Maybe create something simple, something fun. Maybe you just encode something quickly or make a funny song. And there's the Cipher project. But you can also come back and just share your own project, or if you like, you can go back and to look at one of those previous projects. I'll drop those in the chat as well, because I know some people didn't have them when they were looking at the projects before. We didn't have the links for everybody. Great. So all those links are in the chat. Brian, if you could set us up with the breakout rooms again, and folks can pop into those, and we'll come back in. Let's give folks a little longer. Let's do 8 minutes this time. 8 minutes. Okay. So welcome back, everybody. We're going to hopefully have a few people be willing to share their projects. I know I saw some projects I'd love to see. And if you're up for sharing, please raise your hand, and then Brian can kind of keep an eye on you and just take a minute, really just a minute, to show us your project, what you did, and share your screen so we can see what's happening in your project.
Okay, Arthur can share quiz app.
Yeah, let's see.
So this is the, I just modified the quiz app so that it can take to be more of a multiple choice. And the two real modifications were just adding an option to the data structure, and then to use some of the new features that have come in Swift, sorry, in Snap 8 of of being able to prompt multiple items. And so when you run it, it gives you, this is sort of the hello world. So you can select yes or no based upon the question.
Very nice. Thank you. I love this, and I can see your set block actually has those answer options in there. So we're setting the computer science quiz to, is this working? The answer is yes, and your options are either yes and no. Very cool. Any other projects folks want to share?
One suggestion on that last one, just put the correct answer first, and then you don't have to have it as a separate property.
You know how quickly kids will figure that out, though. You'd have to have a randomizer built in. But I like that. That's clever.
Oh, because it presents them in the same order. Yeah, okay. Never mind.
Ken, you got something to share?
Yeah, so at the last SnapCon, I did a project, I showed a lightning talk about a different way to do encryption that involved big numbers. And I tried to show it to my group and it partly worked, but maybe I'll very quickly share my screen and show what was going on here or something.
I see one more hand. Russell, we'll let Russell share and then we'll have a little wrap up discussion and end on time. What do we got here?
The basic idea is to turn the text, like the word hello, into a big num. So the idea is that you treat like a word like hello as if it's in base 2 to the 16 because it's of Unicode goes up that high. So the O just becomes the Unicode. You're multiplying it by 1 here, and the L, the second to last L, you multiply it by 2 to the 16. But then the next L, it's 2 to the 16 squared, and the E, and so on. So each one is just like base 10, except that here it's base. So this much of it at least works. You get a number like this. And then once you have a number like that, the idea is that you could multiply it by some other big number and then add some other big number to get an encrypted version. And then to decrypt it, you subtract this number and divide by this, and you get back to the original number. And then you just do this process in reverse to turn the big num back into text. So it isn't completely working for reasons that maybe have something to do with version 8, because it definitely worked during the last Snap conference, but who knows? So that's what
That's great. Yeah,
so
thank you.
I put the link to it in the chat.
Excellent. Thanks for sharing. Russell, we've got about 1.5 minutes left. So we'd love to see a super quick demo and then a couple of questions to wrap up.
Yeah, can you actually hear?
Yes.
Okay, good. So what I did, I took the Caesar cipher you have here, and I made it so that it can use multiple letters. So hopefully this is going to work. I forgot to add a warp block, but anyway, so essentially this is taking Caesar cipher and turning it into something like Enigma, although it doesn't actually have the reflector. It only has 2 wheels and the plugs are entirely missing.
Wow. I feel like I need to sink into this one. Could you drop this one in the chat also?
I haven't actually shared it yet. It's just here, but I can do that in a few minutes.
Great. Thank you. All right. We've got just a moment or two to kind of contemplate on what we've seen here. I'm going to share my screen and move to wrapping up. So I thought we could kind of talk about, have you used any of these projects with students, or maybe as a student yourself? How did it go? What extensions did you try? Other questions to perhaps respond to is, can you think of other projects that offer what were my criteria for favorite projects? Learning potential, appeal, agency, potential for extension, and simplicity. And then thinking of your own favorite projects, what about them make them your favorite projects? And I'll just open it up for a couple of responses before we close. Any ideas, any thoughts?
I love this framework of learning potential, appeal, and so on. Where does that come from?
That came from my head as I was planning this presentation, but you might see more of it now that it's been generated.
Nice.
I picked a bunch of projects and then I had to ask myself, why am I picking these? Why are these my favorites? And this is what I came to as why they were my favorites.
Mm-hmm.
Great question.
Mary, one of the criteria I use for some of my favorite projects are creativity, which is like artistic creativity. So I made this big pixel project I showed before, and what I love is letting students kind of, like a drawing program, and so letting them kind of draw the pixel level. So kind of artistic creativity I would add as another bullet point. But I love it.
For me, I kind of had it looped under agencies. Like you can be creative, you can customize it. That's how I was thinking about it. But absolutely, creativity is a big thing for me too.
Sure.
Love it.
Susan made a comment in the chat.
Yeah.
I wonder about whether Parsons projects give a false sense of understanding. Would love to just throw that out and see what people think.
That's an interesting question. I think I would use them in targeted cases and not every time. So I think it would be nice, especially in the beginning as we're introducing things, or maybe as an exercise rather than the only opportunity that you get to think about a particular idea would be my off the top of the head idea. Anyone else want to respond to that? And then maybe we'll take that as the last insight. Brian or Dan, any thoughts on that? That's an interesting question.
I'm not a big Parsons Project fan in the first place, so.
For that reason or other reasons?
For many reasons, but I guess, I mean, they're not so bad as assessment items, but as a teaching strategy, it doesn't seem flexible enough.
Mm.
You know, just like use these 5 blocks.
Again, I would lean toward using it in a limited context for particular exercises, and probably for those same reasons.
I think, Mary, I found it a way to bring it to younger folks. So when I was the first version of middle school, I had a range of kids from 8th grade to 4th grade, and I found the 4th graders could work only if I gave them the blocks to play with, and they were just kind of reordering them. And they were still getting there, but it wasn't the same level of learning and same level of ability as the 8th graders, but they couldn't have done the 8th grade problem. So it's a way to kind of grade down something by just telling, here's the blocks to do. And not try to trick them with, here's extra blocks that are, you can make it harder by saying, here's blocks that may not be part of the solution to make it harder. But kind of showing them the palette, I found very nice to be able to grade down something.
Yeah, I love it. Great. Well, I don't want to go too much longer. I'm looking forward to skimming over the chat. Someone else was asking, did I write this up anywhere? It's in the slides, and maybe it'll be written up more somewhere else later. But thank you all for coming, and I have had a great time at SnapCon so far and look forward to seeing you all in additional talks. Have a